Hello everyone. In this lecture, we are going to see ASME Section VIII Division 1 Effect of Hydrotest pressure on a point away from discontinuity. We have all these courses available on our Thinkific platform. To learn more about these courses, register with the link given in the description.
Now this is a shell. The blue color which you see, that is a shell. And there is a nozzle connected to that shell. Okay, very simple diagram. Don't worry about whales and all. Okay. Now there are 2 points. So there is a point A, which is quite away from this nozzle. So we can call it as away from any discontinuity, right? Nozzle is a kind of discontinuity. So there is a point A, which is quite away from a discontinuity. Okay. Now there is point B, which is coming at the nozzle corner. Talking about this point A, the question is, you have designed a pressure vessel with pressure equal to design pressure. Okay. You calculated some thickness and it was exactly the design thickness, required design thickness is coming to 10 mm. There is no corrosion allowance. Okay, corrosion allowance is also not there. Maybe it's SS material. Okay, so you got 10 mm as a required thickness. You made the vessel with 10 mm thickness. Okay, now if I'm trying to raise the pressure equal to the design pressure, what will be the value of stress at point A? So this is the design pressure which is there inside the vessel, right? So when we calculate the thickness, we did for this design pressure, right? So you got 10 mm thickness. Just take an example. You got 10 mm thickness, and that is what you selected for this pressure vessel. So that means when there is a design pressure inside the vessel, the stress will be equal to the allowable, because that is the maximum we can allow, right? That is what we have used in the equation, if you remember. Okay. Is it making sense, guys? T is equal to PR divided by SE minus 0.6P, right? So what I'm trying to do is, first what I did, I took P as design pressure, S as allowable stress. I calculated T. So T, I got 10 mm. Now I'm just putting that 10 mm here. All the values same. I'm trying to find out S. Easy, right? I'll get allowable stress, no other value. Making sense, right? Great. So now my question is, okay, now let us come back to that stress strain diagram. Okay. And now I have increased that design pressure. No, earlier I took as design pressure. So I was getting the stress as up to allowable. If I'm increasing that design pressure, let us say by 1.3 times, let us consider that as M at WP is equal to design pressure. Okay, just for simplifying this situation. So if my hydrostatic pressure is 1.3 times than the design pressure, so at design pressure, how much stresses I'll see? I'll see the stress equal to allowable S. So my stress during hydro also will be 1.3 times the stress which I saw during the design pressure condition. Is it making sense what I just said? So what I was saying, that I applied pressure P. So the stress value was equal to allowable. If I'm, see hydro, we see that roughly we are, going up to 1.3 times the design pressure. If I take MWP is equal to design, so 30% higher than design pressure. So my stress also will go 30% higher than it. That is what I'm saying. Okay. So that's what is expected. Okay. So stress will be going beyond allowable during hydro. Okay. Now that here it is becoming interesting now. So let us this point be 30% higher. Okay. So my stress level is increasing up to this. Okay. Still we are below yield, right? We are not going and touching yield. We are below yield. If you want to see exactly where I am, so if we just put the allowable equal to 2/3 of yield, we are at 86% of yield. Okay. If this calculation you're not able to understand, no problem. Okay. Just think about it. It's a very simple calculation. Okay. So we are at 86% of the yield. So we are going up to 86% of yield. Okay. Much more than allowable. Right? Making sense? So I performed hydro. Okay. So point A is at 86% of yield, very close to yield. Whether that any permanent deformation will happen at A. The question is, okay, I hope you got it. Great. Already answers are pouring. So I understand. I hope you guys have understood. So what I'm saying that whether this path, that point A, which has gone up to 86%, okay, whether any yielding will happen. No, because we are well below yield, right? Any deformation will happen. That is my next question. Any deformation will happen to point A. Whether point A will see any, just think a little bit, a little twisted question. Whether any deformation will happen. Many of you are saying no. Mohit is saying yes. The question is whether any deformation will happen. Yes, Amar is absolutely to the point. Yes, deformation. See, we have already drawn this stress strain diagram, right? So see this strain. Strain is there, right? So strain is what? Strain is deformation. I'm talking about deformation. I'm not talking about permanent deformation. Okay. Many of you might have got confused with permanent deformation, and that is the reason you said no, right? So we are talking about deformation. So see, whenever there is stress, there is going to be strain, right? We know that the stress strain relationship. So yes, deformation will be there. Okay. Deformation will be there, but it is in well elastic limit, right? So now if I remove the pressure, I have increased the pressure for hydro. I am maintaining that, holding it for some time, and then relaxing the pressure. So what will happen in the next cycle? Again, my body will take the same path, right? It will come from A to O. Clear up to that, guys? So O to A, and then when we release the pressure, A will come to O because there is no permanent deformation. So it will follow the same elastic behavior, right? Great.